We are going to be hearing to some other research and innovation and some of the Hungarian experience by Peter Molnar, with the General Director of Water Management in Hungary. So Peter is going to be talking to us very shortly. Peter, you are going to be presenter now. Please start sharing your screen. So Peter has gained his experience in water management at the National Institute for Environment and Ministry of Rural Development in Hungary. Currently, he is working for the General Directorate of Water Management Irrigation Department since 2014. In his capacity, he is dealing mostly with irrigation management, development, and drought monitoring. He is the national focal point of Hungary to the United Nations Convention to combat desertification since 2012. Peter, the floor is yours. Peter, you can start now.
Okay, thank you. Thank you very much for the introduction. And it is an honor for me to attend such a prestigious event. I have a tough job to speak after the previous excellent presentations. In this innovation panel, I was asked to introduce one of the latest ongoing developments in the Hungarian water sector, which is intended to reduce drought risk. As a new development in 2015, the Hungarian General Directorate for Water Management started to establish drought monitoring and early warning system based on agreed and compatible indicators and thresholds, with the aim of supporting Hungarian drought management and water resource management. The design of the system is constructed like the operating Hungarian flood early warning system. It takes into account meteorological parameters, remote sensing data, and the variability of soils. The concept of the drought management is based on these three pillars: observation, measurement, evaluation, and interventions. For drought monitoring, our directorate has established a national monitoring network, which communicates using GPRS remote system. Data deriving from this network arrives to the General Directorate of Water Management database and is made available for users via web-based platforms. Measured and transferred data are used to calculate daily drought index. The novelty of the system is that it integrates soil moisture measurement and real-time data into the calculations like never before in Hungary. Evaluation of water shortage is based on measured data. Based on these two pillars, government assistance can be ensured. The system enables preventive interventions, identification of drought alarm levels, contribute to water restrictions, water regulation, and irrigation support. The monitoring system's heart is a newly developed drought index, namely the Hungarian Drought Index, HDI, which integrates meteorological parameters and soil moisture data, comparing to other indices which are in use or were in use nationally. It has the advantage that provides drought data on a daily basis. It is modular and algorithmic. It is easy to calculate. Only basic data is needed. The previous period's precipitation surplus or deficit is integrated. It is not depending from seasons and can be calculated for the whole country. Its tiered approach makes it possible to calculate the index three different ways, depending on the availability of the data. In areas where no measured data is available, the index can be computed using only the meteorological data, parameters, actual and long-term average temperature and precipitation. But results are more accurate when it is supplemented by stress factors, namely the length of period without precipitation and the number of hot days, which are very relevant for the evaluation of droughts. The combined index as the main product can be calculated in case of measured soil moisture data exists, deriving from monitoring stations. It follows from the foregoing that establishing the monitoring station network is also a prerequisite of adequate operation. As a result of an optimization process, locations of the monitoring station were set countrywide, of which 82 stations have already built. These stations with their respective sensors have already been operating and sending data continuously. You can see in this slide with different colors the schedule of the development starting from 2016, and the development is continuous, subject to the available funds or financial resources. Installment of 18 stations is happening at the very moment. So as a result of the current development, by the end of this year, the number of stations will go up or reach 100. And the aim is to reach 150 stations, which would provide the proper density to provide reliable data. The monitoring system measures air temperature, precipitation, relative humidity, leaf surface moisture as parameters above the soil, and the soil moisture and soil temperature in 6 depths as parameters below the soil. From these, the system calculates the drought indices, which I was talking about on the previous slide, evaporation, field capacity, water deficit and water surplus. Some words on the sensors, the equipments. It is important to mention that the monitoring station equipped with sensors which meet the WMO, the World Meteorological Organization standards. Monitoring station is equipped with for the communication between stations and transmission of data, a core unit with GPRS or radio capabilities, a data logger with GPRS communication, data storage capacity, and digital analog interfaces, an air temperature and humidity sensor, a leaf wetness sensor, precipitation sensor, soil moisture and soil temperature sensors in 6 depths, as I already mentioned. And finally, the power supply of the monitoring stations is provided by solar panels. On the maintenance, during the planning phase of the system, a basic principle was that the monitoring station do not require major maintenance work. It means that we need twice a year read clearance and sensor inspection, cleaning, then every 2 year regular maintenance, sensor change if needed, and calibration, of course. In addition to these, fortunately, irregular maintenance was needed in very few cases so far. Such situations can be caused by power and cable issues or soil moisture sensor breakdown. On the data, measured data from the stations arrive to the Hungarian hydrological database, where the calculated data and index values are stored. The Hungarian Hydrological Forecasting Service works on the data, performing the necessary data check, data validation, controlling the absence of data, and alarm maintenance. On the software, data processing software is also an important part of the system. Measured and calculated data are made available to online platforms. You can see here the addresses of these, and we provide data free of charge. Furthermore, recently a mobile application was also developed by our directorate. These platforms provide the users with measured and calculated data sets, maps with different layers, and series of adjustable graphs displaying the past and present drought situation, and provide a 10-day forecast too. On the future developments, Our development plans include improving further the reliability of the index by installing additional monitoring stations. Integration into the current legislation has also started. On the other hand, the development of soil moisture modeling and its integration into the model, into the monitoring system is also an important ongoing innovation. As part of the the water knowledge export, it is also important to introduce the monitoring system in various international forums. We strive to facilitate further the national and international cooperation. Upgrading the software includes integration of remote sensing indices and making the platform even more dynamic. Let me conclude my presentation with this picture of the so-called famine rock, which is usually a water-covered cliff in Hungary, in river Danube at the foot of Gellért Hill in Budapest, the capital of Hungary. Its name comes from being seen only at low level of the river that only occurs during serious drought, which resulted in the past in very often famine. I believe that such developments I had the opportunity to introduce you today, and the like will contribute to reveal itself as rarely as possible. So, thank you very much for your attention.
Thank you so much, Peter, for your presentation. Quite a wide range of topics, wide range of technologies which are being used at Hungary. Thanks for sharing the Hungarian experience with us. I would like to make a few announcements, please. We are moving very well in terms of timing. We have very well attendance from the participants, and we are having some very good questions which have been assigned already to some of the panelists, and we are going to be addressing them shortly. Please, I encourage everybody to please post your questions and identify who would like to respond back to your question.